Hello everyone, my name is Shrestha Paul and I am from Team Incognito. We are doing an open innovation and the domain that we have chosen is agriculture. The problem statement that we are working on is making a physical prototype for a micro irrigation system in order to increase the water use efficiency of the irrigation sector by implementing IoT and deep learning. Now we can understand that micro irrigation is a modern method of irrigation. By this method, water is irrigated through drippers, sprinklers, foggers, and by other emitters on surface or subsurface of land. Hydroponics means the cultivation of plants in nutrient-enriched water with or without the mechanical support of an inert medium such as sand, gravel, or perlite. In the upcoming days, by 2050, we have to increase the food production by 70% in order to meet the global need for food. And currently, hydroponics is also in use, but for the long run, it needs more technological inputs to make it even better. That is the reason why we are working on ioponics, which is the combination of hydroponics along with IoT and AI. We basically want to bring down the tedious job that is related to hydroponics using IoT and AI so that we can guide the end user smartly about the condition of the crop using deep learning. Also, we can reuse and save the cultivable areas in the domain of agriculture. Now, here is the approach that we are going to discuss. Firstly, we have a microprocessor to which a cloud storage is connected for the transmission of data, and a number of sensors are connected as well, like the pH sensor, ultrasonic sensor, L298D sensor, and DHT11 sensor. And we are going to talk about each of the sensors elaborately in the next part. So this is the hardware that we have made by ourselves, and this is the software part that we are going to discuss. So firstly, the microcontroller. So we know that a microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. Here, the microcontroller that we are using is Node MCU, which is an open source and development board specially targeted for IoT-based applications. Next is the temperature and humidity sensor, DHT11. This is a basic ultra low-cost digital temperature and humidity sensor, which is used to see the temperature of the water that we are using. Next is the pH sensor. This sensor is used to check the pH of the water after it has been treated with fertilizers. Then comes the ultrasonic sensor, HCSR04. This is used to check the water level of the tank from which the water comes. Then comes the motor, which is going to be used to pump the water out from the tank, and this is going to work in a loop. And then the motor controller, that is the L298D sensor, which is going to control the motor. Next is the aeration pump. This pump is used to aerate the nutrient medium, that means to control and balance the oxygen level of the water. And finally, we have the illumination sensor BH1750, which is going to check the sunlight intensity. Thank you. And then I would like to request Randrita to carry on with the presentation.
Thank you, Shrestha. Now, so as Shrestha already mentioned that we have built our hardware part where we can fetch the data from our model, and right now we have uploaded the data to Firebase, the cloud storage, and we have built our own app that is built using React Native. This app this app can fetch the real-time data from Firebase. Apart from that, this app can help in detecting the health of our plants, which can help the end user, especially the farmer, to take care of their plants. And this can be the one and only solution to the entire to farmers, especially our end users. Apart from that, we have a plan of implementing the multi-class classification in the upcoming in the second or the modified version of our app. So this is the model that we have trained using deep learning, especially transfer learning, using RaceNet 152 V2. We have achieved our 94% accuracy, and these are the graphs. Now these are the progress, the thing we have done in last 12 hours. In our first 12 hours, we have built our hardware model and build the basics of API, that entire team. And the second 12 hour, we assemble the entire hardware model. Apart from that, we built our own deep learning model, and in the final time, in the final hour, we integrate our hardware with our software. So these are the basic, these are the our hardware. This is the basic overview of our hardware. The entire model is built by us in during the hackathon only. So thank you from the team.